Hello! In this video, we are going to prove the following theorem. Let F and G be non-empty families of sets, and suppose every element in F is a subset of every element in G. Then the union of F is a subset of the intersection of G. Now, if you recall, given a family of sets F, to say that X is an element of the union of F means that X is an element of some set in F. And to say that X is an element of the intersection of F means that X is an element of every set in F. Okay, now let's get into proving the theorem. Now really, we're trying to prove that everything in the union of F lies in the intersection of G. So give me an arbitrary element of the union of F. I'll call it X. What does it mean for X to be an element of the union of F? Well, it means that X is an element of some set in F. And I'll call that set A. Now, since we want to show X is an element of the intersection of G, what that means is we want to show that X is an element of every set in G. So, we're going to show that for all sets B in G, X is an element of B. So, give me an arbitrary set in G. I'll call it B. Our whole goal from here is to show that X lies in B. Now, we can use the fact that every element in F is a subset of every element in G. Because if we take our element in F to be A, well then A is a subset of every element in G. So in particular, since B is an element of G, A must then be a subset of B. Then, since X is an element of A, this tells us that X must then be an element of B. Okay, so putting this together, we see that under the assumption B is an element of G, it follows that X is an element of B. Since B was arbitrary, this means for all sets B in G, X is an element of B. And that's another way of saying that X is an element of every set in G. So really, we have shown that X is an element of the intersection of G. But then notice, we see under the assumption X is an element of the union of F, it follows that X is an element of the intersection of G. Since X was arbitrary, this means everything in the union of F also lies in the intersection of G. And that's exactly what we wanted to prove. So this completes the proof. And so yeah, that's pretty much it for this video.